All right, we left off yesterday with the Boreal Forest or Taiga biome. Okay, we didn't get a chance to start talking about it because we ran out of time. All right, so like the other biomes, okay, it's fairly large, takes up a fairly significant portion of the Earth's land surface. It's just that almost all of it is in places that are either quite far north or are somewhat inaccessible. Right, it's one that's less disturbed by man than most of the others. Right, less. It can still be because obviously the taiga is a place where in general there are a lot of resources available, right? Not just in the form of lumber and things like that, but also oil sands, coal deposits, okay? Things like that are often very plentiful in this biome. So while it's untouched because of its remote nature, it's getting less and less so because of the available resources that are there. Okay, wildfires can be prevalent. Okay, we saw that back in 2016 when we had all the wildfires up in Fort McMurray in that area. Okay, that is a very natural and normal occurrence. Okay, for the taiga, it can get quite dry there. Certainly, they get a lot of snow in the winter, but that doesn't represent a lot of moisture. It melts and it runs off into the rivers, and the trees dry out quite fast if there isn't an input of rainfall. So, like we say, wildfires are prevalent and they're actually important. Okay, as a forest gets old, a lot of the trees can get sick, they die, they're just standing there. Okay, they're shading out the rest of the stuff that's there on the ground. So it's important that once in a while the nutrients that are tied up in them get recycled. Okay, nature's recycling method, fire. Right, burns them down. Okay, they can decompose a little bit faster. New growth can appear and succeed them. Okay, in a process called succession. Right, so while obviously that fire was tragic and destructive for a lot of people, okay, it is a natural occurrence. It's the way that nature just cycles their nutrients. All right, it's a cold biome because most of the time it's either very high altitude or very high latitude or both. Okay, and so as a result, winters are long, and we have a significant bell curve to this biome, much of which is below freezing. Right, and you can see that quite clearly here. Okay, here is 0 degrees Celsius. It's the line going across. Okay, right here, we can see that for more than half of the year, the temperatures are below freezing, and when they get above freezing, they don't get significantly above freezing for any length of time. Okay, so it's a cold, dry biome. And we can see that because it's a forest, okay, we have fairly regular rainfall, a bit more in August and September, okay, but for the most part, it's relatively dry, right? We're not looking at more than 100 millimeters of rain in even the wettest month, and most months are like 50 or less. Okay, so like I say, it is a fairly dry biome, okay, and spruce trees do tend to be fairly drought tolerant. Okay, questions on that one? Because remember, we could get climatograms and stuff on the unit exam, final exam, and we have to associate those with a biome. All right, vegetation, very much the opposite of the other types of forest. The diversity is very low. That means there's not a lot of different kinds of plants growing in this place. Okay, if you go into like Banff or Kananaskis or something like that, you're going to see basically the same 5 kinds of trees. Right, you're going to see some white spruce, some black spruce, some Douglas fir, some Engelmann spruce, and some lodgepole pine, and that's really about it. Okay, that's what our forests are generally made up of, and they tend to be kind of stratified in terms of altitude. Some of them grow better at different altitudes. Lodgepole pine tend to be a lower altitude type of tree. Okay, as you go further up, you get into the white spruce, black spruce, Engelmann spruce, Douglas fir, okay, things like that as they become higher up and colder. Okay. All right, so for the soils, okay, the soils are quite variable actually. You go into the mountains and the soils are very poorly developed and they're quite thin because there hasn't been as much erosion and building up of the soil, right? So oftentimes you'll see what looks like to be a tree growing right out of the rocks. Sometimes they do, all right? Stuff can kind of gather in the cracks of a rock and that creates enough soil for the roots to get established, okay? But for the most part, okay, you're not looking at very complex soils and they tend to be fairly acidic because the needle litter that comes off of most spruce and pine are acidic, okay? So they get in, they fall to the ground, they start to decompose, they release these acidic chemicals into the soil, which essentially keeps anything from growing around the roots of the tree. right? It's how it kind of keeps other competition away. Its own roots can tolerate it, but other plants can't. It's why you very rarely see anything growing under a spruce tree. If you have one in your yard, you know that the grass doesn't grow under it very well. Okay? All right, and then for the animals are very unique in this biome because they have to be tolerant or have some way of dealing with an extremely long cold winter. Right? There's basically two ways to do that: stay or go. So a lot of animals will go. They migrate. They go somewhere else for the wintertime. Okay, and they're in a different biome, okay, during winter where it's going to be warmer. Other ones stay. Now, if you stay, you have a choice of remaining active or hibernating, okay, going dormant. Hibernating is fine as long as you're able to do that. Not all animals are effective, true hibernators. A grizzly bear is not a true hibernator. Okay, their metabolic levels don't drop significantly during the winter. They sleep a lot. They're not all that active, but they're not at a lower metabolic state. Okay, if you look at like a ground squirrel or a gopher or something like that, these are animals that do truly hibernate. Their metabolic rates drop significantly. Okay? If you were to pick up a hibernating ground squirrel, you'd think it was dead. It would be curled up in a ball. It would be stiff and cold. Okay, their body temperatures can drop, okay, sometimes down to like below 20. Okay, their heart will beat once, twice, 3 times per minute. Okay, they don't breathe very much. Okay, very shallow breaths that you'd hardly even notice. Okay, they are a true hibernator. Right, they reduce the amount of calories that they would require during the winter in order to survive. Right, every once in a while they wake up. Okay, they shiver for about an hour to get their metabolic rate back up, okay, body temperature back up so they can move around. They eat a little bit of the stuff that they had stored and then they go back. Okay, that's kind of how a true hibernator deals with winter. Okay, your other option is to be active. If you're active, then you have to have some sort of burrow, okay, that can protect you from the extreme cold when you are inside of it. Okay, snow is an excellent insulator. Okay, and it's an excellent insulator for a few reasons, and this we talked about earlier in the unit. Okay, first off, it has an extremely high albedo. It's white, so it reflects back any radiant energy. All right, so if you've got something warm inside of there, it'll reflect all that energy back. Okay, secondly, there's tons of trapped air. Just like in the pink fiberglass insulation, snow traps a lot of air. It's fluffy. Okay, as a result, it's a very good insulator because conduction can't happen if the air can't move. Right? Similarly, conduction can't happen, right, through air because air is trapped in the snow. Right? So snow is a very good insulator. So a lot of animals will create burrows under the light, fluffy snow. There is a problem though. Okay, if any snowmobiles or anything like that come along and compress the snow, it loses virtually all of its insulative ability. All the air gets pushed out, and now it's not a good insulator anymore. Right? So anywhere where the snow can get packed is not a good place for them to build their burrow. So that's why they usually build them in kind of the lee of a tree, okay, or something like that where the snow is less likely to be disturbed. Okay, yeah, but snow is an excellent insulator. Anyone ever build a quinzhee? Okay, so a quinzhee is like kind of an emergency snow shelter that you might make if you were stranded in the woods at night in the wintertime. Okay, all you have to do is make a pile of snow. Okay, so you just pile it, don't pack it. Because if you pack it, obviously it's just not a good insulator. You just have to make a pile of snow and then hollow it out and crawl inside. Okay, super easy to build, only takes a little bit of time. We used to do this when I taught in Lloydminster. There was actually a snow ecology unit in our curriculum. So I would wait for the coldest day of the year. And I would take my students outside and tell them in the football field, make a big pile of snow. Make several big piles of snow. And so they do that. And they would do it gladly because it was the only way they could stay warm because it was like minus 35. So if they were shoveling snow, they stayed warm. Right? Then, okay, now hollow that thing out. They would hollow it out, get inside. And by the time they got inside, they were sweating after like 5 minutes. Okay? But they could get it above freezing inside of the quinzhee. Okay? They would actually have drops of water falling on them from the snow melting a little bit on the inside. It'll melt for a little bit and then it'll form a crust so that doesn't happen anymore, but initially it does. Okay? And they would stay quite warm inside this quinzhee. Right? So it's snow is a great insulator, and if you're going to stay, you got to be able to deal with that. Okay? If you're moving around a lot, you have to either be able to penetrate the deep snow with your legs and reach the ground, or stay on top of it and float. All right? So the feet of animals that live in the taiga of the winter is one of two choices: a pole or a snowshoe. Right? It's one or the other. So if we're talking about a moose or a deer, their legs are like a pole and it can just go right down into the snow and reach the ground. Okay? If they're like a snowshoe hare or Arctic fox or something like that, they have much wider feet and they spread their weight out and they don't fall into the snow unless the snowshoe hare is trying to hide from something. Okay? Anyone ever see it? Like a snowshoe hare, they'll run if they're being pursued and then they'll jump really high into the air, hit the snow, and they just disappear. Because they penetrate through the snow and they just sink right inside. Then they'll just dig their way out when the predator is gone. Right? But it's how they can hide from the predators. Okay? And that snow can get quite deep. Okay? I had a friend of mine when we went cross-country skiing in junior high. We'd stop for a break and we were told, don't take your skis off. He didn't take his skis off. He never listened. Okay? Took his skis off and kind of jumped off the skis and sank into the snow right up to his neck. Okay? And his hands were stuck. Like he was like literally like this in the snow, and he couldn't get out. We had to dig him out, okay, because he had sunk into the snow. It was that deep. All right. So there are some large herbivores. There are some small ones. So our predators, okay, are kind of like a general purpose type of predator. Sometimes they can take down, they're strong enough and fast enough and mean enough that they can take down something bigger, but also small enough and quick enough that they can still catch the smaller rodents and things like that when bigger prey items are not available. All right, so things like black bears, okay, or wolverines. Okay, wolverines are pretty much just a predator. They pretty much only eat meat, but black bears and grizzly bears will eat pretty much anything. All right, they'll eat berries. Okay? They'll eat, like leaves and stuff like that, and then they'll eat animals when they can catch them and when they're available. Right? But being an omnivore like that really does make your success rate a lot better because you have lots of choices in what you can eat. Okay? You do have to be mindful, though, obviously, if you're walking around in this area when the berries are out, because the bears are everywhere. Right? And when they eat berries, they just take a branch, stick it in their teeth, and go and pull it through until the berries fall off. Okay? And then they just eat all the berries. It's also an important time to watch where you're walking, because when they eat lots of berries, they get the runs. The bear scat is just nasty. Okay, yeah. Watch out. If you see like a tree and it looks like all the branches are kind of stuck together, don't touch that tree. A bear used that to wipe its butt. It's really gross. And actually, those parts of the tree will die. It's like really nasty stuff. So stay away from it. Okay. These are all important survival points. Okay, really. All right. And then chemical cycling. Chemical cycling in the taiga is really, really slow because winter dominates. It's winter 8 of 12 months or more, right? So it's frozen, it's cold. Fungus doesn't get a good opportunity to get a foothold on anything. Bacteria are shut down most of the year. Insects are dormant. Okay, so it takes a really, really long time for anything to break down in the taiga. And then we have tundra. Okay, so the tundra biome is an Arctic grassland. Snow can persist for 12 months. Okay, it may not be everywhere, but there'll certainly be banks of it, drifts of it that will persist for the entire year, which means that the soil typically doesn't thaw, or at least not very far. Maybe the first few inches will thaw, okay, but after that there'll be permafrost, okay, what we call permafrost, which means the soil is always frozen. That is what prevents large trees from growing in that area. They cannot penetrate far enough into the soil to get a good set of roots established. Right? So what you see is basically just a grassland. Everything is very low to the ground, okay, and you have, like you say, snow persisting. Okay, that picture is taken July 6th. Okay? There's still a significant amount of snow present on July 6th. All right. Other things, daylight in winter, non-existent, right? We're talking very northern types of places, right? So there's going to be radical changes between winter and summer in terms of daylight. And then obviously in the summer, okay, like right now, there would be 24 hours of sunshine. So these plants can, when they get that sun and they get growing, they have 24 hours worth of day to collect all of their sunshine, can carry out photosynthesis and get things done, which is important because they have a very short growing season. Okay. All right. Okay, the climatograms for the tundra. Okay, similar to the taiga. Obviously, only a few months, maybe 4, where the temperature gets above 0, and it doesn't get significantly above 0. Okay, the warmest temperature might be a little less than 10 degrees. In terms of precipitation, okay, also fairly dry. The wettest month is around 65 millimeters of rain. Okay, most of the months are 50 or less. All right, so it can be pretty dry, and most of that is because it falls as snow, and snow doesn't represent a lot of moisture. All right, and again here, guys, you can see that in the tundra, there's not a lot of trees, okay, maybe a few bushes here or there, okay, and snow presence, okay, again, well into July. Right, this is July 8th for that one. Okay, vegetation, okay, tundra actually means treeless, right? So we're looking at mostly grasses, a few like sedges and things like that, some shrubs, lichens, mosses, things like that. Snow cover is important because snow insulates and protects the plants against not only the cold, but also the abrasive effects of blowing snow and ice, right? If ice crystals get moving, okay, at a high rate of speed, it's no different really than being in a sandstorm, right? In a sandstorm, you get all that sand blowing at a high rate of speed, and it can literally strip the skin off you, okay? So if you're a plant and you're exposed in the wintertime to all of this, it'll just rip those parts of your tissue apart. So if you got a branch exposed, it could tear the bark off, okay? Things like that. So you want to have snow cover in order to protect you in the wintertime. Okay, and that's it. That's it, that's all. All right, so that's it for biomes, okay? Now you might want a sheet of paper out so you can write down the stuff I'm going to do here for the unit exam review. Obviously, guys, this is a pretty short unit. All right, there's not a lot of material here, but that means you need to know that material well. Right? There's lots of things I can ask about that limited amount of material. So if you've missed something in terms of the material, you need to make sure you're caught up, because I could have 3 questions on that bit of material. All right, first thing we went over in this unit, okay, was we talked about climate. You definitely need to know the difference between the components of climate and the factors affecting climates. Okay, the components of climate are temperature, precipitation, light, and wind. Right? The factors are things like latitude, altitude, proximity to oceans, mountain barriers, prevailing winds, ocean currents, all that stuff that we talked about. Okay, so you need to be able to apply these 2 ideas, okay, the components and the factors, okay, to an actual place. On your unit exam, what I'm going to do is I'm going to put a map on there, and I'm going to indicate a particular point on the map. Okay, based on that location, you need to tell me what you think the climate there will be like. And in that, you have to tell me, here are the factors that affect this place, and here's the climate they will produce as a result. Exactly what you did in your climatograms activity. All right, so you got to be able to figure out what the factors that affect that place are, okay, and then tell me what you think the climate will be like. All right, it will be some place that is relatively familiar. Okay, I'm not going to pick like some place in Nicaragua, okay, like that you're not familiar with, right? It'll probably be a Canadian city, right, so that you have some background on that. Okay, climatograms. We already said that you're going to be asked to interpret one. I'm going to put one on there, and then you're going to have to tell me what it says. Okay, so look at it. Oh, this has a bell curve on it, so it's not near the equator. All the temperature bars are very high, so this place is quite wet. This must be a temperate forest biome. Okay, something along those lines. Okay, so you're going to have to tell me what biome it comes from by explaining what you see in the climatogram, and then fitting that in with what you know of a particular biome. Right, that will be a written response item. Okay, the stuff on factors and components will be in both. The written response is the question I talked about with the map, okay, and there'll be some other things in the multiple choice. All right, third thing, energy transfers on Earth. Okay, so you need to know like the 3 parts of the Earth: atmosphere, lithosphere, hydrosphere. Okay, how does energy get transferred in those 3 places? So that conduction, convection, radiation, right? Things like that. Okay, so if we're looking at those three areas, okay, within the atmosphere, okay, it captures energy through radiation. Okay, The air can move because it's a fluid, and moving air is typically called wind, so convection is wind, okay? And latent heat can be transferred through the atmosphere. When water evaporates, that water vapor can be taken from one place to another, where it would then condense and release all of that potential energy. Okay, for the lithosphere, obviously, yes, we would absorb energy through radiation. The amount of energy received would be determined by the absorbed would be determined by the albedo. Okay, is that place covered in really dark soil or rock or a rainforest? Okay, or is it covered with snow that would reflect a whole bunch of it away? Okay, and most of the energy transferred through the lithosphere is through conduction, so it doesn't play a really big role in terms of global energy transfers. The role of the lithosphere is to provide a place for plants to grow, for absorbed energy to be converted, okay, from solar energy to chemical energy by photosynthesis. Okay, and then we have the hydrosphere. Okay, again, energy is absorbed through radiation. Energy can be transferred by convection. That would be ocean currents in this case. Okay, that can move the energy from place to place, and it is usually the supplier of latent heat. Okay, or rather, the water vapor that is going to transport that latent heat, because obviously the hydrosphere is made of water. Okay. What are the three things that can happen to solar energy when it strikes the Earth's surface? It can reflect, be absorbed, or be, it hits plants, what's going to happen to it? It'll be converted. You need to know those three things. I guarantee you there will be a question that will give you a picture and say, what's going to happen to the energy here? Okay. What happens to energy is always the same: absorbed, reflected, converted. What you will have to do is determine which of those is going to be the dominant thing. Okay, look closely at the picture and go, okay, well, are there a lot of plants here? If there are, then there's going to be a lot of conversion. Okay, if it's covered in snow, then there's going to be a lot of reflection. If it's, not covered in a lot of plants, or the plants are dormant and it's just dirt, then, okay, you can say most of it will be absorbed because this has a dark color. Okay, you have to kind of analyze the picture yourself. Okay, so if it's absorbed, there will be an increase in energy and thus an increase in temperature. Okay. If it is reflected, then there's basically no change because no energy was absorbed, it just bounced off. And then lastly, if it's converted, that's by photosynthesis. Okay, changes light into food energy. Okay, remember that any questions you get on this unit exam have to do with natural environments and situations. Okay, when I ask you what can happen to light when it strikes the Earth's surface, the last thing I want to hear is about solar panels. Okay, inevitably I get people saying that it's really important in terms of global energy for energy to be converted by solar panels into electricity. No. Okay, we are talking about natural systems here. Okay, the last time I checked, there are no solar panels sitting on the ground out here. Okay, there's a few there in Drake Landing, but that's really about it. Okay, we're talking about natural ecosystems here. Okay, the only conversion we're worried about is sunlight into chemical energy by plants through photosynthesis. Questions so far? Okay. Then winds. Okay, you had the lesson on global wind patterns, right? So know things like, the trade winds, the Coriolis effect, and how it causes prevailing winds. Okay, so there's that convection that's always going on. More energy is received at the equator than is at the poles, so it's naturally warmer at the equator. Hot air rises, cool air moves in to replace it, but the whole time that's going on, the Earth is spinning underneath it, which makes it seem like the wind is not coming from the south, okay, or from the north, but coming from an angle, right? Which is why our prevailing winds come from the southwest, right? They should really just come from the south, but they come from the southwest because they're being deflected, okay, by the fact that we're moving through the air as the air moves as well. Okay, it's like if you are, if you just stand outside today and there's no wind, you don't feel any wind. But if you get in a car and stick your head out the window, it feels windy. Okay, it's not that the air is moving; it's that you're moving through the air. All right, and that's the same thing with the Coriolis effect. The air is moving, but we're moving through it while it does that, and that makes it appear like it's coming from a different direction. All right, so make sure you know Coriolis effect. Okay, make sure you know how prevailing winds happen. That's that combination of convection. Okay, energy. You know, there's the second law of thermodynamics. Energy's got to go from hot to cold, but the Earth spins underneath the air while it's trying to do that job. Make sure you do a good job of explaining how those two processes go together. All right, other things that'll be important, the jet stream. Okay, the jet stream is super important in terms of moving heat energy around, okay, from different latitudes. Okay, it also moves lots of moisture. Okay, it can carry warm air masses from one place to another. So it's that high speed, high altitude wind, okay, that transfers energy from different latitudes. Okay, so it's important for that. And especially for transferring and moving latent heat around. Right, so you're going to have lots of situational questions where you're going to want to apply these kinds of things. If it's asking about, you know, how you know, a warm air mass might move from the equator to the poles, then you can talk about convection. You can talk about Coriolis effect. You can talk about the jet stream. Okay, you can talk about that latent heat is moving with that air mass and bringing stored potential thermal energy with it. Right, try and work all that stuff into your answers. Okay, then we talked about heat capacity. There might be a couple of multiple choice questions just about what heat capacity is. Okay, but the problem solving part of it will be in the written response. Just be able to use this formula to solve a heat capacity problem. Okay, after we did heat capacity, we talked about latent heat, okay, not just what it is, but also how to solve latent heat problems, the heating curve of water problems, okay? So latent heat, remember, is energy that is needed or given off during a state change, okay? So when ice melts into water, or when steam condenses back into water or whatever, okay? So there's latent heat of fusion, that's for melting or freezing. There's latent heat of vaporization, which has to do with evaporating and condensing. Okay, and you will definitely be asked to use this, okay, to solve latent heat of water questions or heating curve of water questions. Okay, so make sure you go over a few of those. I think I have one or two in the review package. Okay, because the other day when we did this, we talked about how there's not really any difficult math in one of these problems, but there's a lot of marks. Okay, even a 3-step problem could very easily be out of 8 marks. Okay, and I'm not sure what these numbers were for. I would just ignore those. I must have had something on my mind when I wrote those, but I don't remember what it was. Okay, and then lastly, we just talked about biomes. Remember, you're going to have to be able to identify one from a picture and a description, or match it up with a climatogram. Actually, both. Okay, you'll have to do both on the unit and final exams. Okay, so make sure you're able to do that as well. Okay, I still have one more thing to go over on Monday with you guys, and that's relationships in the community. It kind of goes back to energy transfers, food chains, okay, things like that. That stuff is on there only very generally, okay, but I do still need to teach that one lesson on Monday, right? And then we'll start our final exam review stuff, okay, at that point.